We all love Python because it's so simple, right? But what if I told you that that very simplicity is kind of hiding some serious superpowers? Well, today we're going to unlock the powerful, game-changing features that are humming along just beneath the surface of the code you write every single day. So you probably feel pretty comfortable with Python. You've got your loops down, you know how to write functions, you've even built a few classes. But the real magic, the stuff that makes incredible frameworks like Django or Flask even possible, that lies just a little bit deeper in a few key concepts we're about to explore. I mean, think about those annoying problems we all run into. You need to add some logging or check how long a dozen different functions take to run. What do? Just copy and paste the same code everywhere? Or what about this? You've got this massive gigabyte-sized file to process. Do you just cross your fingers and hope your computer has enough RAM? These aren't just theoretical questions. These are problems with real solutions built right into Python.
So here's the plan. We're going to dive into three core superpowers: decorators for powering up your functions, generators for handling huge amounts of data like a pro, and context managers for automating all that tedious cleanup. Then we'll take a quick peek behind the curtain at the deep magic that makes it all tick.
All right, first step, decorators. This is your first step to writing code that's not just functional, but truly clean and powerful. Think of these as power-ups for your functions. So what exactly is a decorator? Well, at its heart, it's just a function that takes another function as its input, adds some new functionality to it, and then returns a new, enhanced version. It's like gift wrapping your original function with cool new abilities, all without ever changing the gift inside. And that little @ symbol you see all over Python code, what's that about? It's just some nice, clean syntax, what developers call syntactic sugar, for a really simple idea. Writing @myDecorator is exactly the same as doing this on the bottom line. You're just taking your function, passing it through the decorator, and assigning the result back to the original name. That's it. It's a wrapper. Okay, so where would you actually use this thing? Think about any task you have to do over and over again. Need to log every time a function gets called? Boom, a decorator. Need to time how long a database query takes to run? Yep, a timer decorator. Or how about making sure a user is logged in before they can access a certain part of your app? That is a perfect use case. It's exactly why big frameworks like Flask and Django use them for everything, from defining web routes to handling permissions. All right, our next superpower tackles a totally different beast: efficiency. If decorators are all about enhancing a function's behavior, then generators are all about enhancing its performance, especially when you're dealing with mountains of data. Okay, so a generator is this special kind of function. Instead of returning a single result and being done, it yields a sequence of values, one by one. The best way to think about it is like a Pez dispenser that's, well, kind of lazy. It doesn't spit out all the candy at once. It just gives you one piece every time you ask for it, creating it right on the spot. And that means it can produce a huge sequence of data without ever having to hold the whole thing in memory. And this right here, this is the whole ball game. A normal function has to build that entire list in memory all at once. If you have 1,000,000 items, you need space for 1,000,000 items. That's what we call O of n memory usage. But a generator? It only ever holds one single item in memory at any given time. It yields a value, then it just pauses and waits for you to ask for the next one. Its memory usage is constant, O of 1. And trust me, for big data, this is an absolute game changer. And that brings us right to where you'd use them. Reading a 10 gigabyte log file line by line, a generator is pretty much your only sane option. Want to do something crazy, like create an infinite sequence of numbers, maybe all the prime numbers? A generator can do that no problem. Anytime you're building a pipeline where data flows from one step to the next, generators let you do it with unbelievable memory efficiency. Okay, our third main superpower is all about making your code safer and more reliable. Context managers are Python's super elegant solution to a common headache. How do you make absolutely sure things get cleaned up properly no matter what happens? So a context manager is basically any object that's built to work with that with statement you've probably seen. Its entire job is to handle the before and after for a block of code. It sets up some resource when you enter the block and, this is the most important part, it guarantees the cleanup of that resource when you leave, even if your code crashes with an error inside the block. Here's how it works, step by step. When Python sees a with statement, it calls the object's special __enter method. That's where you'd open a file or connect to a database. Then your code inside the block gets to run. And as soon as that block is finished, for any reason at all, Python automatically calls the __exit method to handle all the cleanup. It's a guaranteed automated teardown. Look, you've probably already used the most common one, with open file.txt. The reason you never have to remember to write f.close is because the context manager is doing it for you, automatically. This same exact pattern is used for database connections to make sure they either commit or roll back, and for managing locks and threading to prevent really nasty bugs. It just makes your code cleaner and so much more robust. All right, so we've seen these awesome powers. Now, let's take a quick peek behind the curtain. Let's look at the foundational magic that actually makes some of this stuff possible in the first place. First up are closures. A closure is basically a function that has a memory. It remembers the variables from the scope where it was created, even after that outer function has finished running. And if you were wondering how decorators really work under the hood, well, this is the secret sauce. That inner wrapper function in a decorator, it's a closure. It remembers the original function it was supposed to wrap. And then we have meta classes. Now, this is some seriously deep magic. Think about it like this. If a class is the blueprint for an object, a meta class is the blueprint for a class. It lets you hijack the process of class creation itself. Now, you'll almost never need to write one of these yourself, but they are the source code of power behind frameworks like Django's ORM, which uses them to magically turn a simple Python class into a complex, powerful database model. So the big takeaway here is that these aren't just some weird academic ideas you'll never use. They are the absolute building blocks that make all those elegant, powerful tools you use every single day in Python possible. They're the magic behind the magic. So let's just quickly wrap this all up. This table is basically your cheat sheet. If you want to add new behavior to a function without touching it, you reach for a decorator. Need to process huge amounts of data efficiently? That's a job for a generator. And if you need to guarantee resource cleanup, you use a context manager. It's that simple. Look, understanding these concepts is what takes you from someone who just writes Python code to someone who really understands the language and knows how to use it powerfully. You've got a whole new set of tools in your toolbox now. So the only real question is, which superpower are you going to try out first?